Here's a video tutorial for quiz 19M. Right, number 1, we've got amount, we got time, and then we got half-lives. Starting off, we have 4 grams. Here's the most common mistake that people made. They did not start at time 0 or 0 half-lives. They started with 1 half-life, or they started with 5,730 years as their beginning. And you always are starting off at time 0. So that was the number 1 mistake. There would be 2 grams left after 1 half-life. There would be 1 gram left after 2 half-lives. There would be 0.5 grams left after 3 half-lives. I could fill all this in. This question doesn't ask for how many years, so I don't need to do that. This question is a little bit different because it says 3.5. 4 half-lives would be 0.25. 3 half-lives is 0.5. So halfway in between 0.5 and 0.25 is 0.375 grams. Okay, let's go down to number 2 and 3. Most common mistakes on this were that people didn't know what that number meant. That number means the mass. Since this is a graph of protons and neutrons, silver has 47 protons, 94 mass, minus 47 protons gives us 47 neutrons, which means this dot is right about there, which is on that red line in this picture, but below the line of stability. So not stable, and then a lot of people just didn't explain why. Below the line of stability. So if you wrote your dot way up here, then I had to get it wrong, because you were talking about something very different. If all you said was it's not on the line, that's not an explanation, really. For number 3, same thing, lead 220 is the mass. Lead has 82 protons, so 138 neutrons. That's not even on this graph, but it would be way like up. Let me get full screen so I don't. Sorry about that. Alright, so we'd be like talking way up here, probably actually even higher than that, to get to 138. So we already know it's unstable. So you could say we need to either make this go down to get to the line of stability or over to get to the line of stability. Therefore, I said that this thing has too many neutrons. Or you could have said it has too few protons. Either one of those would work to get it, or why it was not on the band of stability. Okay, number 4 is pretty straightforward. Again, this one was, only thing about this, and I accepted 2 different answers, was whether it meant 3/4 left or 3/4 to go. So we've got amount, I've got time, and half-lives. The amount, we don't know the amount, it doesn't say. If this was a percentage, we would say it's 100%. If it's a fractional thing, I could say that it's a whole amount, which would be 1. And again, that's at time 0 with 0 half-lives. So 1 half-life would get it down to 50% or 1/2. So if you were talking about, that's 18 days. If you thought that, read it as, oh, I was looking for 3/4, which would be in between there, then 9 days would have worked as an answer. Otherwise, if we want to go until 3/4 is gone, then we would go another 18 days, which is 36 days total. 2 half-lives gets us to 25%. 1/4 is left over, which means 3/4 is gone. So that would be 36 days. I accepted either answer. Number 5, again, some people got thrown off by this graph, and a lot of people just assumed that I was asking for what that point was. But I think we'll see why when we set this up just like normal. We've got amount, time half-lives. Starting off, it would have 100% at, again, 0 times 0 half-lives. That was a common mistake. 50% is 1 half-life, which is 5,730 years. 25% is 2 half-lives. 12.5% is 3 half-lives. And that's where this graph is leaving off at. So I think most people just assumed, oh, well, it must be 4 half-lives. But 4 half-lives would only be 6.25%. We need to go down to 3.125, which is 5 half-lives. So if you did 5,730 times 5, 28,650 years. Finally, we've got number 6. A couple people use different approaches to solve this problem. We want to end up with 2 grams after 24 days. Okay, so percentage-wise, 24 days, 2 grams, we're kind of just comparing it to how much should actually be there. So one way you could do this is you could say that, well, with 24 days, that's 12.5%, and 12.5% is 12.5 over 100, and we want the part that's left over to be the number 2. Therefore, we can solve this now and compare these again. This is about 6 times greater than this, so if we divide this by 6, pause for just 1 second here. Okay, just a quick point of clarification here then. On the quiz, this 24 was kind of cut off and it only looked like a 2. So that's kind of the difference in this setup here. Let me get this back to where we're talking about here. So anyway, the method of solving it would be the same thing. That 24 days was about 12.5%. And we could cross multiply and say 12.5x equals 200. Okay, 12.5 will go into 108 times. So it would go into 216 times. 16 grams. Now, again, when you originally took the quiz, if you're looking at Classroom IQ, it really only, all we could see was this 2 days, because it was kind of off the screen, off the margin of the paper for some reason. In that case, it would be the same thing, only instead of looking at this point in the graph, if that's 4, then that's 2. So we're talking somewhere around there, like 85, 90%. So I'll say 90% over 100 is equal to 2 over something. Okay, again, we could solve this with cross multiplication, or we could think about it factorially, that this is 45 times less than this. Most people ended up giving me an answer of about 2.5, 2.25, something like that. If you said 2 grams, it couldn't be 2 grams because that's how much was left over. It couldn't. If you said less than that, that didn't make any sense either. So thinking about the percentage and the proportion was how to solve that problem.